Y'all ready to dunk on this test? That's what I'm talking about. Oh man, what in the world are we doing tonight? I don't know. I am exhausted. We just had a study session with Pre-Cal 12, but guess what? We're going with round 2. Let's go. Oh, I almost made that one. I've never made it before, but that's okay because we are going to some math. And look at that right there, 8:41. I started at 8:41. Nicole, Maddie, I know that you were worried about me starting on time. Sorry if I am starting a little bit later. I'm getting to the I'm getting that link to you a little bit late, but it's literally back to back. I'm doing study sessions tonight for about an hour and a half. So if I looked a little dazed, if I say some weird stuff tonight, it's more entertainment for you and weird for me. Okay, so hey, we'll get this thing underway. Hey, let me first start off by saying that tonight we're going to go over a couple of things, specifically those that were my 5th period. We're going to say some things today that are a little different from what you heard in class. There's not a whole lot of new stuff, but especially at the beginning, there's just a few things that are tweaked and just changed a little bit. And as I look down below, we have 7 viewers already, 8 viewers and climbing, along with my Sweden followers. Oh man, this is going to be a good night tonight. Hope you're ready. We will go through as many as we possibly can. We will stop around 9:20, but if need be, we can go a little bit later because I care about you and I want you to be successful. All right, you can do it. I want you right now. I want you to look at the screen and I want you to say, I can do it. Yes, you too. Yes. Okay, let's get it underway. I do have a couple things to mention in terms of the review session. So, or just in terms of just the review in general. Okay, so a couple things. I'm hoping that you can see this here. But I did want to just kind of show some stuff to you. So first off, you can take out number 9. Okay, you can take out number 9. And by the way, as we go through, if you do have a question, Lawrence, yes, you can do it. Yes, you can. You can do it. I believe in you, my man. Lawrence just texted me, I can't do it. So no, that's not true. You can do it. So 9, you could throw out number 9. Number 10. Please do me a favor, keep this between us, but let's throw out number 10 for me. The reason why I'm going to tweak that just a little bit, going to give you a different one tomorrow. But number 10 you could throw out. And then the other one that I saw too that I want to throw out as well, and I'm going to actually extend this just a little bit, is number 14 too. You could throw out number 14. I understand that some of you, specifically in my 5th period, you already had done that today. It's not that it won't matter. I'm not saying it doesn't matter. It's just going to be a little bit different in the way you approach it. Okay. All right. So just a heads up there. Now, what we're going to do is this. I'm going to ask that you do the following. Okay. First off, I had someone that texted me some questions regarding some things that they struggled with, and so I want to get to those questions first. Then after I get to those, while I go through them, some of those questions are probably ones you have as well. But if not, please put those here, and I'm just going to include those in the queue, and then we'll go through those together. Sound good? You G to G, I'm G to G. Last study session of the year. Whoop, whoop. I probably lied because I'll do another one with the exam, but that's okay. All right. So, man, do I have so much energy? This is weird. Okay, let's go here, and I do want to I'm gonna pull up my email here because I did tell. All right, perfect. Okay, so right now I want to go through the following, and we'll actually do these together. We're gonna start at number 11 here. We'll do number 11, and then we'll just slowly progress through, okay? All right, so let's do number 11. First off, a couple things with these word problems. Don't let these word problems get you down, okay? All right, what I mean by that is let's just dissect what it's saying, okay? First off, it gives us some information. It tells us that this equation of 183, and if I mess up in writing this, let me know here. Yes, Lawrence, I can do that for sure. But this one, sorry about that. Let me look in here. There we are. We're going to just write down 183 e to the 0.043, okay? And it's actually 0.043 t, okay? Now, one of the main things that you need to understand is what are we solving for? All right, so as I read this, it says the size of the beaver population at a national park can be described as this function, where f of x is the population of beavers, okay? All right, so here's the beaver right here, all right? The beaver population, all right? Right here. And what we're trying to do is we're trying to see, okay, with this beaver population, right, on this side, I don't know how to spell population, you know. But this, what is the beaver population over 6 years? So we know that it also says that T represents the time in years, okay? So this is time in years. Just like I told you earlier today in each class, label what you don't know, right? And also, you know, E, that is not a variable. That's an exponential function there, okay? So we're going to then take this, and what we can do is we want to find what is the beaver population. So the question is that I'm trying to find is this right here, when the time is T, which is 6 years, okay? So when 6 years is there, what is the beaver population, okay? So what we're gonna do is we're gonna plug 6 in for T, okay? So what we have now is f of x, which is what we're trying to solve for, equals 183 e to the 0.043 times 6 power, okay? This is all the power here, okay? I got the power, all right? So we're gonna take this now. We're gonna plug this in our calculator. Now, if there is a question on how to plug things in our calculator, we'll bring those up later, but I think we're good on this. We can actually just plug it in the way we see it. So 183, and I always put a parentheses just to be sure. E to the power of parentheses 0.043 times 6, okay? All right, so we'll put another parenthesis. Let's close that up there. And just in case, okay, just in case here, I do want you to kind of see just a glimpse of this here. Not my lovely face, but this here. This is how I would plug it in, okay? So just a heads up. So make sure you have those parentheses if you're going to put it all in one. But my answer would be 236.86, 236.86. And the important thing to kind of also understand is when you do this, you want to make sure that you know what you're rounding to. All right, DT had a great question earlier. He asked, hey, coach, is it one of those things where you just round it to the second decimal? And normally, yes, that's the case, but you don't want to assume that. So like, for instance, on this one, it does say round to the nearest whole number. So on this example, we want to get every point we can. We round to the nearest number, which would be 237 beavers that are there, okay? That's the amount that we solved for. Again, as I go through this, if you do have further questions, please stop me at any time and provide those questions, just like Lawrence did earlier. Lawrence, I appreciate that, man. Okay, so this next one talks about the function f of x, okay, equals 1 plus 1.5, okay? So we'll put this up yonder, ln to the x plus 1, okay? So just like we said before, let's figure out what do we have? It says this models the average number of free throws a basketball player can make consecutively during practice as a function of time, where x is the number of consecutive days the basketball player has practiced for 2 hours, and so on and so forth. So x is the number of days, okay, days practiced for 2 hours, okay? So we're trying to find this. It also says this whole thing models the average number of free throws, okay? So this right here is the average number of free throws, okay? So this is, again, a model that we're using here, all right? And that's what we're looking at on that one. Yes, so Lawrence, you're exactly right. Because 206 is a function of time, this is in terms of days, right? We can assume that that is the only thing that makes sense is plugging it in for x. So let's say this was Lawrence's free throw percentage in 8th grade basketball here, and we get 1 plus 1.5 ln times, or ln of, not times, ln of 206 plus 1. Okay? So just like before, we'll plug this bad boy in. Okay? So 1 plus parenthesis 1.5 ln of 207. Okay, so we're going to plug that in. And we then get, oh, I'm sorry, this is not percentage. I put average number of free throws. That's what I say, made consecutively is what it said. But this said 8.99, which is approximately, I think it said the nearest free throw. I'm not sure on that. If it's 8.99 and you put 9 and you put something like this, I would take either answer, okay? I would take either answer. But that would be the correct answer in terms of number 12, okay? Number 12 there. Another thing you might want to do is after maybe watching the podcast, I would recommend if you're watching right now, maybe get your questions in and obviously do that. But if you're watching a second time or even a third time, it might be beneficial to pause it and do the problem and then check it with what I put there and see how you got your answer and what you did wrong. So just a heads up on that, okay? All right, awesome. Let's go to, I'm just going to go in order. Lawrence, I appreciate you telling me that, man. 17 and 18. Let's go to number 18 here. We'll do a graphing one. And then we're going to go to another one there in a second. So this one is y equals 4 to the power of x plus 3 and then minus 2 on the outside. So let's go through a couple things. First off, transformation-wise, we know the x plus 3 transforms it opposite, left and right. So this is going to go left 3. And the negative 2 on the way outside is going to go down 2. Okay, so left 3 and down 2 are the transformations. And we also know that y equals 4 to the x is the graph that we're graphing. Okay, so we're going to start with this one and then graph it. Again, some of you do it a little different. And if you do, it's not wrong unless I don't like you. Okay, some of you I don't. No, I'm joking. I'm completely joking. I love all y'all. All right, so this one would be, we'd plug in -1, 0, 1, and 2, right? And remember, because of the fact that this is 4 to the x power, we're just going to keep plugging these values in for x, okay? Plugging them in for x. How did I get 8.99? I plugged, let me see here. Okay, let me do this. I think this might help. All right, let me, and I just got a text. I'm getting texts from people, which is perfect. And I want to make sure I hit on that. Lawrence, I got your text. I'll be right with you. And log graphs, I got that one too. We will get to log graphs too. Maddie, if you could help me with that, don't let me forget that one, okay? 8.99, let me see here if I can help with this. Let's see. Let me put this here. The best thing to do is just show you my calculator here. Calculador. We ate Mexican tonight, so it's just kind of one of those things where I start speaking in Spanish every once in a while. But this is what I got. This is how I got it there. I put 1 plus parenthesis 1.5 ln of 207. The big thing that I would be careful of if you didn't get that, I would do it step by step. So maybe ln of 207, get that answer, then multiply by 1.5, and then add 1. Because if you don't do the parentheses, it will mess up, just like in your situation that you were talking about there. But that's a good question. Does that make sense? Hopefully that makes sense there. And Maddie, I'll come back to that one there. It might be a good one just to transition to. We'll do a log graph one here in a second, okay? All right. Good stuff. Okay, so let's keep going. Okay, let's plug in a value of 2. So 4 squared would be 16. 4 to the first would be 4. 4 to the 0 is 1. And 4 to the negative first, let's just talk over that. That means we can flip this, okay? So 4 to the negative first would be the same as like 1/4, okay? Because we can flip it. So 1/4 would be the value here. So what we've got now is x comma y, so -1 and 1/4, 0 and 1, 1 and 4, and 2/16 way off, so don't worry about that. Let's just do this one where the traditional graph with no transformations would be here. And note that the horizontal asymptote is always going to be, without any transformations, it will always be y equals 0, okay? Left and right. Think opposite, left and right, even though you think normally y is up and down, but it goes through 0 right here, and that's why we say y equals 0. So now we transform this. So now we're going to go each point, we'll go left 3 and down 2. So we're going to go left 3, 1, 2, 3, down 2, 1, 2. Left 3, 1, 2, 3, down 2, 1, 2. Left 3, 1, 2, 3, down 2, 1, 2. So this graph, again, very similar to the other one. Might be helpful to do it in a different color. The asymptote also will go left 3. So do this. This might be actually helpful for you. Pick that point right here that it hits the y-axis and go left 3, 1, 2, 3, down 2, 1, 2. So what it does now is it's now going to go here, okay? So what was at 0 now goes left 3 and down 2. Notice the left and right doesn't make a difference, but when it goes down, it does. So this new graph, which was at y equals 0, now is at y equals -2. Okay? All right, and that's how we did it there. Hopefully that helps there on that one. Okie dokie. Okay, we can do the next one here. Okay, you can go back if you need to. Someone said do number 17. So we can do number 17 here. 2 to the x minus, I think it's x minus 3. I just want to make sure. Man, I think it is. It's hard to see on my sheet here. There you are. Yes, it is. It was hiding a little bit with +1, right? Okay, so 2 types of transformations. We're going to go right 3, and we're going to go up 1 a little bit. We're going to take those transformations, okay? On the previous one that we were saying, this one right here, the asymptote was y equals -2. Okay, that would be the asymptote right here. Okay, it was at 0. Again, we took the point where it crossed 0, 0 and went left 3 and down 2. Even though this isn't a point on the graph, we took it left 3, down 2. And because it's here, this is the graph, or this is the line it's approaching, which is at y equals -2, because it crosses at that spot. Okay. Okay. Y equals 2 to the power of x minus 3 plus 1. Okay. So our transformations go right 3 and up 1. Okay. Those are the 2 types of transformations. So now we're going to graph y equals 2 to the x power, y equals 2 to the x. So we're going to graph that first. So we're going to go down below. We're going to go here. We're going to go x and y. So we got this and here. So we're going to go -1, 0, 1, and 2. Again, when I graph it, when I plug it in, I get out certain values. So plug in 2. 2 squared is 4. 2 to the first is 2. 2 to the 0 is 1. 2 to the negative first. Remember, -1 means that we flip, do the little flip-de-flip, flip-de-flippity, and we get 1/2, okay? So we get -1, 1/2, 0 and 1, 1, 2, and 2 and 4. So very similar to the last one. Maybe not as steep. We're going to get something like this. Again, notice the transformation has a, without any transformations, it is traditionally at y equals 0. Okay? Awesome, awesome. Okay, so, and then Nicole, I did get that one. Don't let me forget that, okay? I'm going kind of forward, but I will come back in just a little bit, okay? So what we've got now is the transformation. We'll do this one in bleu. So we're going to go right 3 down and up 1. So this is going to go right 3, 3, up 1, right 3, up 1, right 3, up 1, and right 3, up 1. So this graph is going to go here. Now, with this, remember, it's normally at 0. So this point, this is the asymptote, by the way. This is going to go right 3 and up 1. So this is actually going to be a horizontal asymptote at 1. So this is, again, the blue one, which is the new graph. So this is going to go up yonder. This is going to approach this way. So the new asymptote for the blue one would be y equals +1. And that's how I would graph that line. Okay? Great questions. How come I did not subtract by the 3? How come I did not subtract by the 3? Oh, why when I plugged up here did I not subtract by 3? Great question. Remember, I am taking out all transformations. So notice I took out the -3 and I took out the +1, right? I took them out because I am graphing the original graph first, y equals 2 to the x. Then once I graph that, I get what was in red, okay? So I did the red one first, right? Red one first. But then to get to the blue one, I then transformed every one of the points right 3 and up 1. Right 3 and up 1. So I graphed it using that and then kind of went forward off that there. Okay. Does that make sense? Text me back. Make sure we're getting it there. If you don't understand that, make sure we're good on that one there. Okay. Whew. Okay. We are rolling. You see me rolling. Let's do 19. Okay, let's do 19 here. Shout out to Savannah's mom if you're watching this. All right, just a little shout out. I've been giving it the last couple times. Why not do it again? Get a little shout out there. Okay, so we got the graph that's here. Let's go to the transformations here. Okay, let's go transformations. Just like we did before, okay? So just a heads up, just like we did before, we are going to take out the transformations of -2 and +1. So this bad boy is going to go right 2 and upward 1. So we're going to hold on to that, okay? Maddie, hopefully this helps there, okay? Yes, I know what the song means, okay? The people are making fun of me and first of all, you make fun of my height and then my singing ability. Don't appreciate it, okay? Just don't appreciate it, all right? So we have log base 3 of x equals y, okay? Log base 3 of x equals y. And so what we can do on this one, notice again, we're taking out the transformations. We cannot graph this, though, until we change it to exponential form. So what we want to do here, just to kind of review, we want to take the value that is the base of the log. This is a big deal. Star this or do whatever you need to do because changing from log to exponential and exponential to log is huge, okay? If you don't know how to do this, it is going to be very hard to do well on this test, okay? So just kind of note that. So the 3, we shoot to the other side to change the exponential form. And the y goes from being on the first floor to being up in the basement. So it kind of moves it on up, okay? Moving on up, okay? Get out the way, get out the way, get out the way, move, okay? So we were going to get out the log out of the way, leaving x by the left side, okay? So x is equal to 3. Remember, y goes to the top floor, 3 to the y power, okay? Hopefully that helps you out there. So we're going to graph x is equal to 3 to the y, and we can do that, but this time, notice the only difference between this and exponential is the fact that I'm plugging values now in for y because now it's equal to x. So we're going to plug these values in as -1, 0, 1, and 2, and that's always when I have a log, when I'm graphing a log, okay? Always, always, always. And by the way, when I'm doing the form in blue, this is now going to have a vertical asymptote, except now it's going to go through the x-axis here, and this would be x equals 0 at that spot, okay? So plug in 2, 3 squared would be 9. 3 to the first would be 3. 3 to the 0 would be 1. And 3 to the -1st, we do the flip to flip, flip it to flip, and we've put it on the bottom to get 1/3, okay? So we got 1/3. But the only thing you need to be careful on is just be sure to do the x and then the y, right? So this is going to be 1/3 comma -1. So 1/3 to the right, comma -1. The next one is 1, then 0. So 1 to the right and 0. The next one is 3, 1. And the next one is 9, 1. Okay? Or 9, 2, I'm sorry. Bad Coach Jay. Bad Coach Jay. Sorry. We want to go up to 2. There you are. Okay. So this thing is going to go down for real. Come down here. All right. I'm getting crazier and crazier, y'all. And I'm by myself. I'm literally I'm tired. It's one of those things more entertaining for you. That's just kind of how it rolls there. All right, so we got our original one, which is right here with our point here, 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 and here, but kind of over on that side. Okay, so all of these points now need to go right 2 and up 1. So what we want to do with this is we want to push all of them right 2 and up 1. This one's going to go right 2 and up 1. If it lands on it, that's okay. Right 2, up 1. This will go right 2, up 1. So this thing is going to go something, connect it, connect it, connect it. Now, a couple things before you finish off here, okay? We're not quite done. This orange asymptote would be very helpful if we started at 0 and also go right 2, down 1. So this is going to go right 2 and up 1. So you'll notice that since it's a vertical asymptote with a log, this thing is going to go right straight through. And this would finish off with something that looks like this here. Okay, so it's going to approach it, creates an infinite crack in the graph, kind of approaching it, but not quite. So the orange one's the first one, the purple one would be the second one. Okay. Woo! Oh man, this is good stuff right here. I tell you what, man, this is good stuff. Okay, let's go to number 25. I did tell Jack we would do a couple of these in his absence because I know he is out right now. And I told him I would do it. So we have a log of 1,000. Okay. How do we simplify a lot of these? These are, again, ones that are pretty basic in terms of not a lot of steps. But if we don't know the process or the steps that involve this, this can be a little bit difficult. So let's talk about a couple things. First off, if we don't have a base here, it's understood to have a base of 10. Okay. So if there is no base, we will do a base of 10. And actually, let me do this first. Let me see which ones. Oh yeah, let me do this one. Let me put this one down too. Let me put number 28 down as well. Okay, because this one, very similar. Very, very similar. Okay. So in both of these circumstances, you will not have a calculator on either of these. The goal is to get the values on the outside, yada and yada, to be able to equal what the base is on each of these logs. So in both of these problems, the ultimate goal is to simplify by getting both bases to where they're alike to where we can cancel. Okay. So what we would like to do here with 1,000 is get the 10 down below. And the 1,000 would be 10 to what power gets me to 1,000? Well, 10 times 10 times 10 would be 3 zeros. So 10 to the third would actually be what 1,000 would be here. Okay. And again, as I notice this, I say, hey, wow, 10 and 10, they're the same. So we could cancel these out, leaving me with just a value of 3. Okay. So the answer to 25 would be a value of 3. Okay. Now, similar to this one, our goal is to try to get to where we have a base of 4. And Lawrence, I see that on 15 and 16 there. We'll get to that. 1 over 16, we want to have a base of 4. So 4 to what power on the top gets me to 1 over 16? So let's talk through this. 4 to what power is regular 16? Well, we know 4 squared, right? 4 to the second power is positive 16 on the top. But to make it to where it's 1 over 16, we got to do something just a little different. Well, we remember that if I make this negative 2, that means what was on the bottom goes to the top. And actually, 4 to the negative second is the same as 1 over 16. So what we would have now is log base 4 of 4 to the negative second. These 4, since they're the same, will cancel out here, leaving me with a value of negative 2 left over. Okay, so negative 2 would be number 28. Okay, all right, let's go to number 31. I believe I did 31 in class. Let me see. Let's see what one we got. We'll do 31 and 32. Yeah, we'll do 31 and 32. Let's do that. Okay, so we got 27 to the x minus 4 equals 9 to the x plus 2. Look at that. I just read in your mind. Did you just see that? That was impressive. Someone just asked me, Coach, could you do number 31? Guess what I'm putting down right now? That's what I'm talking about. Número 31. Right there. Okay, number 32, I'm also going to do, I'm going to put it on the bottom right here. And that'll be 4 to the power of 2x minus 1 equals 6 to 4. I think that's 2x minus 1. Tell me if I'm wrong. I think that's right. Okay, so let's do a couple of these. First off, whenever I'm trying to get this, when I have this here, and it's a non-calculator, right? I'm not going to give you one that's extremely like difficult where you have to like figure it out with a calculator if you have no calculator on that. Okay. The key of this is to try to get where both sides of these, both on 31 and 32, have the basis to where they are the same. Now, the most missed part of this is someone's going to come here, I promise you. And when you do, I'm just going to tell you, I will haunt you. I will literally come to your college and I will haunt you if you do this. Do not divide by 9. Don't do it. I'm telling you right now, someone's going to do it. And I'm going to be angry. And then I'm just going to throw stuff. It's going to happen that way, okay? So don't do that. What we want to do here is to get to where the bases are alike. And to do that, we got to think to ourselves, is there something that I could put to a power that would be the same on both sides, but that would also equal 27 and 3? Well, as I look at this, I can think, okay, 3 to the third power I know is 27, right? So we're going to hold on to that. And I know 9 is 3 to the second, which helps me out because now I know that 3, right, 3 base here and here is the same. So really, that's the hardest battle. So what we can do is, because we have an exponent to an exponent, we can distribute this here and here to where we get 3 to the power of 3x minus 12 equals 3 to the power of 2x plus 4, because we distribute 2 to each one. Since 3's are the same, we do a little cancel pate. Get the kazoos out, get the paper hats out. It's time for a pate. And then what we can do is subtract by 2x to get x by itself, okay? And then I would get x minus 12 equals positive 4. Add by 12, add by 12. X would then be equal to positive 16, okay? So again, that's number 31. If you're confused or if you want to check it, plug it back in for x. So if you plug it back in for x, you can check it, see, okay, is this something that's true, and that might help you out there, okay? Now, number 32, here we could try to get the bases to where they are alike. One cool thing is that this 4, we could try to see if we have like 4 to some power gets me 64. So like we could know like 4 times 4 is 16, but 16 times 4 is actually 64. So we could actually place 64 with 4 to the third power. So we have 4 to the 2x minus 1 equals 4 to the third. Do a little cancel pate, leaving me with 2x minus 1 equals 3. Okay, because again, I didn't have to change this left side because it already was 4. But since we use the one-to-one property, meaning the bases are alike, we can add by 1 on either side, giving me 2x equals 4. Divide by 2. Divide by 2. X is equal to a value of 2. And again, you could check this by plugging 2 back in for x. 2 times 2 is 4, minus 1 is 3. 4 to the third is 64. And that is, again, a good way to check your answer. Okay? Ha. All right. Good to go. 15 and 16. All right. 15 and 16. Yeah, those are good ones. Okay. I will tell you. We'll tell you this. Both 15 and 16 are the same ones. I want to do number 16, mainly because, oh, actually, I did both of them in one point. I'll do 15. Let's do 15. So let's talk through this one again. Okay, very similar to what we did earlier. We want to put down the exact equation. So A equals 4,400 e to the power of 0.046t. Okay, so we're going to put that in. Let's talk through a couple of things that we also need to know. All right. Let me make sure. Can you do 32 like you did on 30? Yeah, 30 and 32 are very similar. Yes, 32, you would put in 2 to the power of, I think, 5. 2 to the 5th power is 32. Check me on that, but I believe so on that one there. Okay, it says this. The value of a particular investment follows a pattern of exponential growth, hence the equation. In the year 2000, you invested money in a money market account, okay? Some of you weren't even born in 2000, I think, or maybe you were born in 2000. It then goes on to say the value of your investment, T years, okay? Yeah, Lawrence, that's possible. You did get the same answer, by the way. That's just a heads up. So T is the amount of years, okay? Years after 2000, because you started in 2000, right? So we're going to hold up on that. Next part says the value of your investment T years after is given by the exponential growth model. When will the account be worth 5799 or 5,799? So this is the account. This is my amount after T years. So it's basically my amount of money, okay? Money right there. So money, the amount of money after a certain amount of time would be A. So for A, it's modeled by the equation, and A would end up being 5799. So we're going to put in 5,799 in for A, and we're just going to plug this value in. Remember, it's asking us when, right? So if it's asking us when, we're talking in terms of T, and that's T is in terms of the amount of years there, okay? So we're trying to solve for T. So question, we're trying to get T by itself. We can't take ln quite yet. I know a lot of people would do that because this E has to be by itself first. But we know it's being divided, so we can divide by 4,400 here. Okay? And you could then get a decimal on this part here if you wanted to. But what you would get then is 5799 over 4,000, or you can wait till the end, by the way, equals e to the 0.046 t power. So what we want to do is get rid of e, and the kryptonite of e is ln of whatever this is. And so we'll do the same thing on the left side, ln of 5,799 over 4,000, okay? And ln and e cancel out. So what I'd like to do is this. Let me go back to here. Let's get this. Graphic calculator. Get that going. All right, what we got here? Okie dokie. Let me make sure I see this. So we're going to do the ln of 5,799 divided by 4,000. Notice the parentheses, and we'll press enter. So that is the left side. But then don't forget that we then have to divide by 0.046 to get t by itself. So we're going to divide by 0.046 to get t by itself. And when we do that, we get 8.07 years. I think it said round to the nearest year there. So it would be, oh, it's 4,400. My bad. Oh, bad Coach J. Bad Coach J. Wrong. Wrong you are. All right, let me do this again. I'm sorry. ln of 57. Nicole, what would I do without you? And Lawrence, what would I do without you? Yeah, no. What's hilarious is everyone's texting me right now. Wrong number. I'm bad. Bad Coach J. Right now, bad Coach J. Okay, so we got 4,400. Divide that out. And then I'm going to divide this by 0.046. And when I do that, I get my final answer in years, 6.00. You could say 6 years. And if it's 6 greater than that, you would do 2006, okay? 2006, because it's 6 years after that there, okay? Whew, okay. Man, this is fun right here. I tell you what, right now, I'm having a blast. I hope you are too. This is just Gucci. Hold on, where are we doing? There we go. Hold on, where are we at? Okay. Whoa. That's funky. All right, let me go back here. Oh, there we are. Okay, so number 8. Let me go over here. Number 8. Okay, this one's very similar to the one we just did, okay? Very, I mean, like extremely similar. And there goes my phone there. It's dead now. Let's go to, I'm just going to talk through this one. If it's okay by y'all, I'm going to, because it's 9:20 already, I'm going to keep going. Okay, I'm going to keep going for y'all. Going to go overtime, go a little extra time, but I'm going to make sure I'm not going to go pull up my calculator just for sake of time here, and just because I need a little break for tomorrow before we get right after it tomorrow morning. So if there's maybe one that I didn't hit as in depth, we will go through it much more in depth tomorrow morning if you want to get here, get there early there. Okay. Okay. So in this example, what it's asking or what it's telling us is that 400. We're trying to find what x is, right? 400 e the 0.005 t equals 1600. Much like the previous one, our goal is to solve for t here. So that's our goal. And we could do that by first getting e to the 0.005 t power first, okay? So what we're trying to do is we're going to divide by 400 on either side, okay? So we're going to divide by that to get the zeros canceled out. So I get 4 on the right side and e to the 0.005 t on the left side. So what we can do now is to get rid of that e, I could take the ln of both sides. This cancels out. It's like kryptonite. You get 0.005 t equals ln of 4. Divide by 0.005, 0.005. And what you could do is to plug it in your calculator, I would do this part first, ln of 4, then I would take it and divide by 0.005, okay? I think that was Maddie. Maddie, does that make sense? I'm hoping that makes sense. It's still coming through. Your questions are still coming through, so if you do have other questions, let me know, okay? Wow, I forgot, man, let's see here. Okay, so I got that one. I'm trying to go through questions, make sure. Arena, if you're watching this, I'm so sorry. For some reason, your messages didn't come through. They just came through on my came through on my email. So I'm going through Peyton, same thing. Yeah, one thing that Peyton, you had asked me that I wanted to address is you don't have to go through, you don't have to do both lines, meaning you don't have to do the original and the transformation. You don't have to do that, but if you want to, you can. But if you just want to do one, that's fine as well. Okay. I know Nicole on 15. I know I did 15 and 16. 13. I didn't quite get to 13. Let me go back and see if that was 1, 2. And Nicole, you're right on those. Okay. All right, let me get to there. Okay, good. And I'm just making sure I'm going through my all my stuff here. 10 and 12. Okay. Let me see what 10 is. Okay, 10, if you looked at the beginning of the podcast, 10 is not one that we'll need to do there. And if you look at the previous part of the podcast, you would check it out and notice that I believe I did number 12 on that one as well. Okay, check that for me, but I believe I already did 12. 12 was the one with the like basketball player on that one. Okay, all right, good stuff. Okay, I'm getting some other things in here. Oh yeah. That's good. Nicole, I'm going to finish with this one, okay? Is that cool? I'm going to finish y'all with this one. If y'all have more questions, feel free tomorrow to come on by, and I would be more than happy to address any questions y'all have, especially before the test. I'm hoping that this was helpful. I think we hit pretty close to all of them. Maybe except for this one, okay? So first thing to note is I'm going to give you both of these formulas on the test, okay? All right? So I'm going to give you both of these. Now, one of the key things to noting both of these is if I hear continuously, compound continuously, then I am immediately going to this equation. If I hear compounded semi-annually, annually, whatever, any of these, then I'm going straight to this equation, okay? So let's actually use that one as a, for instance, here. I just shut it down. Go right here. So this one says on number 13, find the accumulated value of an investment of 1270. Okay, so the whole value, the value that I originally had is P. That's going to be 1270. Okay, so 1270 is my P. That is my principal. Okay, my principal. So 1270 is what I would put in for my P. Let's keep reading. It then says it's at 5%. Okay, compounded annually. The reason why I'm using the bottom formula is because it automatically goes to compounded annually, right? It is not continuously, so that's why I go to the bottom one, all right? Even though a lot of these things you plug into the same thing. So 5%, be sure to put in 0.05, same thing up here. Put it in as a decimal, so don't put in 5 for 5%. You want to make sure you put in 0.05 because you put it over 2 decimals, right? 2 decimals, okay? Then we ask what would be plugged in for N. Well, N would be the amount of times this compounds each year. Well, since it's annually, you're going to put 1 in for N, and you'll put in for both spots right here and right here. But if it was semi-annually, as it could be tomorrow, you'll put 2 in for N. If it was quarterly, you put 4 in for N because it compounds 4 times a year, and so on and so forth. Now, as far as T goes, the amount of times in years, they say they want us to find the investment, what it's worth, when we plug 11 in for T. So what we've got is A is equal to 1270 times this to the 11th power. So you want to go inside the parentheses first to get this. So divide 0.05 divided by 1. Then I add 1. Okay, so we get this here. So you get 1.05 to the 11th power. And then once I do the exponent, so 1.05 to the 11th power, and my calculator is coming up. 1.05, let me see here. It's coming up here. 1.05 to the 11th, and then we'll take that and multiply it then by our value of P, okay, which was, what was it again? 1270. Sorry, I'm getting distracted. A, I'm tired. B, for some reason, when I'm looking up here, I'm focused on other things coming in there. So something my fault there. All right, it's coming up here. While that's coming up, I do want to go over one more thing. All right, so let me make sure I do this right. So 1.05 to the 11th power, press enter. And then I'm going to multiply that by, what was that again? Make sure, 1270. I was making sure on that. Multiplied by 1270. And my answer, we'll do it to the nearest penny, is $2,172.13. $2,172.13. And that would be what my A is equal to. Again, remember I multiplied by 1270 down below, okay? All right, okay. All right, Maddie, the last thing, I'll say this last thing before I head out, because I'll need to head out here. Actually, I go to bed in the next about 30 minutes, so I'm gonna need to get it going. But what I can say is this. When you solve logs here, on the first page, the one thing I can tell you is what am I solving for? So so what I mean by that is if I have one that is for instance log base 2 of 4x minus 1 equals 6, right? In this instance, you obviously can't simplify this left side because of the x here. So what we can do is we can actually shoot the 2 over and make this into exponential form to get 4x minus 1 is equal to 2 to the 6th power. And then once I get here, once you start that first step, makes it much easier. Another one that's just a little different is if I had 6 ln of 6x equals 36, one thing I can do is to note that ln of 6x is what I would like to isolate first, because I know I can use e, but I got to divide by this 6 first. So I do it to both sides, getting ln of 6x equals 6. Then what I can do is take e to the power, because again, e and ln is at kryptonite, to where I get 6x equals e to the 6th. I can plug that in my calculator and divide by 6 on both sides. So why am I saying all this? I know that that's probably maybe confusing you more, but what I can say is tomorrow, if you do have more questions on that, feel free to bring those in tomorrow morning, and we can go over some more together. But one thing I would do is just kind of go through using maybe the formula or using the answer sheet on, hey, what is my first step in these problems? How do I execute that first step? And once I get what that first step is, a lot of times you'll be golden on that. Okay. Okie dokie. Wow. I will tell you what, y'all's questions, and I don't just say this, I'm not just saying, y'all's questions might have been the best that I've ever had. Fantastic job. I know that tonight was very extensive. I know this test is not necessarily the easiest for a bunch of different reasons. You know, I know with only 3 sections and different things, it's just different, and I get that. Just know that I'm here for you. We'll go through some more tomorrow morning. We'll have about 15 minutes before class Wednesday and Thursday before y'all's tests. Other than that, hope y'all have a great day. I'll post this review again so you can check it out, and we'll go from there. Thank you all so much. Oh, yes, before I go, the traditional throw. Can Coach J make it? Here we go. That was not even close. That was not even close. Have a great night. We'll see y'all later. Bye.